Right now, at this very second, something the size of a small car is drifting through absolute darkness, so far from home that light itself needs an entire day to catch up with it. It weighs about 720 kilograms, roughly the mass of a grand piano. It is nearly 50 years old, older than most people watching this video, older than the internet, older than the personal computer. It is moving at more than 61,000 kilometers per hour. Fast enough to cross the continental United States in about 4 minutes, and it is currently over 25 billion kilometers from Earth, a distance so absurd that if you tried to drive there in a car at highway speed without stopping for gas or sleep or the heat death of your engine, it would take you more than 28,000 years to arrive. Nothing built by human hands has ever gone further. Nothing. Its name is Voyager 1. And what it just picked up in the silent black between the stars is something that, according to every textbook written before it got there, was not supposed to exist. Stay with me, because by the end of this video, you are going to understand why a single, faint, almost musical vibration detected by a spacecraft older than most of your electronics is quietly rewriting what humanity thinks it knows about the space between the stars, and why one specific moment in November of this year is about to change the relationship between our species and our own machine forever. Before we go any further, if you love stories about the real edge of science, the actual frontier, not the hype, hit that subscribe button and ring the bell. This channel goes deep into the strange, verified, mind-bending reality of what's happening in space right now, and you don't want to miss what's coming next. All right, let's go. To understand why what Voyager 1 just did is so impossible, you have to understand what it was originally built to do, which was, honestly, almost nothing. Rewind to September 5, 1977. A Titan III-E Centaur rocket lifts off from Cape Canaveral, Florida, carrying a small boxy probe wrapped in gold foil and bristling with antennas. NASA had a modest job for it. Fly past Jupiter, fly past Saturn, take some pictures, send back some data. That was the assignment. A 5-year tour of 2 big planets, and then, presumably, silence. The engineers who built it did not design it to leave the solar system. They did not design it to survive for half a century. They did not design it to become the most distant object in human history. They designed it to do a job and quietly die. Voyager 1 had other plans. In March of 1979, it swept past Jupiter, and the images it sent back stunned scientists. It discovered a thin, faint ring around the giant planet that no one had known was there. It found 2 brand new moons, Thebe and Metis. And when it looked at Jupiter's fiery moon Io, it saw something no human had ever seen before on another world. Active, living volcanoes, erupting in real time. It was the first proof that another body in our solar system was geologically alive. Then, in November of 1980, it reached Saturn. It found 5 more moons. It discovered a new ring called the G ring. And when it looked through the thick orange haze of Saturn's largest moon, Titan, it detected an atmosphere rich in nitrogen and hydrocarbons, a chemistry so complex that scientists began to whisper about lakes. Lakes of liquid methane, on a world nearly 1 billion miles from the sun. None of that was in the original mission plan, but none of that prepared anyone for what came next, because after Saturn, Voyager 1 kept going. It climbed up out of the flat plane of the solar system, angling northward into deep space at 3.5 astronomical units per year, and NASA quietly extended its life. New mission, new goal. Find the edge. Find the boundary where our sun's influence ends and true interstellar space begins. That boundary has a name, the heliopause. Think of our sun as a bubble. Not the star itself, but the invisible bubble it inflates around itself with the solar wind, a constant hurricane of charged particles blasting outward in every direction. That bubble is called the heliosphere, and it is our home. Everything you have ever seen, every planet, every asteroid, every human being who has ever lived and died, has existed inside that bubble. The heliopause is the edge of the bubble, the wall. And on August 25, 2012, Voyager 1 punched through it. For the first time in the 4.5 billion year history of our solar system, something built by hands, wrapped in gold foil made of 1970s computer chips, crossed into the space between stars. Stop and sit with that for a second. We did that. A species that only invented the light bulb about 140 years ago sent a machine across a wall that nothing from our sun's neighborhood had ever crossed before. But here's where the story gets strange. Because when Voyager 1 crossed over into interstellar space, the scientists back on Earth had a problem. They couldn't be sure. Its main instrument for detecting the solar wind, the Plasma Science Instrument, had stopped working back in 1980, dead for over 30 years. So when Voyager punched through the heliopause, the team saw cosmic rays go up and heliospheric particles go down, and they suspected, but they could not confirm. Then, almost a year later, one of the probe's other instruments, the Plasma Wave Subsystem, picked up something in the darkness. Oscillations. Vibrations in the plasma around the spacecraft. And those vibrations told the team mathematically that Voyager was now moving through a much denser sea of particles than anything found inside the sun's bubble. Confirmed. Voyager 1 was outside. And here is where the first truly impossible thing begins, because scientists had always thought of interstellar space as, essentially, empty, a vacuum, a void, a silent, dead nothing between the stars, the kind of place where instruments have nothing to listen to because there is nothing there to make a sound. They were wrong. In 2020, a young Cornell doctoral student named Stella Koch-Acker was digging through years of raw data being trickled back from Voyager 1's plasma wave system, not the loud stuff, not the eruptions caused by the sun sending shock waves out into the galaxy. She was looking underneath all of that, in the quiet. And in the quiet, she found something no one expected to find. A hum. A steady, faint, persistent, narrow-band vibration in the plasma of interstellar space itself, not caused by the sun, not caused by a distant flare, just there, a tone, a drone, a pulse of the medium between the stars, humming in a frequency so narrow it was almost like a musical note. It's very faint and monotone because it is in a narrow frequency bandwidth, Acker said when the discovery was published in Nature Astronomy in May of 2021. We're detecting the faint, persistent hum of interstellar gas. Cornell senior author James Cordes, the George Feldstein Professor of Astronomy at Cornell, described it with an analogy that has stuck with astronomers ever since. The interstellar medium is like a quiet or gentle rain, he said. In the case of a solar outburst, it's like detecting a lightning burst in a thunderstorm, and then it's back to a gentle rain. A gentle rain. In the space between the stars, think about that. Everything you have ever been taught about the void between stars, the black, the silence, the vacuum, is not the whole story. There is a subtle, structured, constant activity happening out there, and we only know about it because a piano-sized probe, launched in 1977, is still listening. That is discovery number 1. And it should have been the ceiling of what Voyager 1 could tell us. It wasn't, because the second impossible thing Voyager 1 revealed is that the density of the interstellar medium is not what our models predicted at all. Acker's team realized that continuous tracking of the plasma density out there, something no telescope on Earth can do, was suddenly possible. Cornell research scientist Shami Chatterjee put it perfectly. We've never had a chance to evaluate it. Now we know we don't need a fortuitous event related to the sun to measure interstellar plasma. Regardless of what the sun is doing, Voyager is sending back detail. The craft is saying, here's the density I'm swimming through right now. And here it is 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 now. Voyager isn't just a probe. It has become a permanent, moving lighthouse in a sea nobody has ever mapped from the inside, and that matters to you. Personally. Because for the first time in human history, we are beginning to understand what our solar system's protective bubble is actually pushing against out there. What shapes it? What squeezes it? What determines whether our little sunlit sanctuary stays intact or gets deformed by the invisible weather of the galaxy? This is the atmosphere of our neighborhood, and until Voyager, we had never even taken its temperature. But there's a third turning point that almost nobody talks about, and it happened not in space, but here on Earth. In November of 2023, Voyager 1 started sending nonsense. Every packet that came back through NASA's Deep Space Network was pure gibberish, ones and zeros with no readable science and no readable engineering data. The most distant machine humanity has ever built had, in essence, started speaking in tongues. For months, nobody could figure out why. In April of 2024, JPL engineers finally pinpointed the cause. About 3% of the memory in Voyager 1's flight data subsystem, the onboard computer responsible for packaging every piece of information the probe sends home, had been corrupted. A single tiny chip inside a computer built in the 1970s had died. 2 possibilities, NASA said. Either an energetic cosmic particle had struck it, or, after 46 years running non-stop in the cold black between the stars, it had simply worn out. NASA JPL, now think about that repair job. The patient is 24 billion kilometers away. Any command you send takes almost a full day to reach it. Any response takes another day to come back. and you are trying to remotely rewrite ancient assembly code, moving pieces of a 46-year-old program around a broken chip on hardware you cannot touch, cannot see, cannot restart if things go wrong. And they did it. The engineers at JPL, some of them not even born when Voyager launched, brought it back from the dead. The data started flowing again. If you're feeling even a little bit of awe right now, do me one favor. Drop a comment below with the word still, because that's what this spacecraft is. Still going, still listening, still teaching us, and it helps this channel keep telling stories about the real, verified frontier of science. Now let's talk about the humans behind all of this. Because it's easy to look at Voyager and think of it as a triumph of technology. It isn't. It's a triumph of patience. There are engineers at the Jet Propulsion Laboratory in Pasadena who have devoted their entire careers to a spacecraft they will never see, never touch, and never bring home. They inherited it from a generation of scientists who are mostly retired now, some of them gone. The mission's original imaging team leader Carl Sagan died in 1996. Donald Gurnett, the principal investigator on the plasma wave system that later detected the interstellar hum, spent decades listening to signals from a machine he helped design when he was still young. Every year, Voyager 1 loses about 4 watts of power. The plutonium inside its radioisotope generators is slowly, patiently decaying, and there is no way to refuel it, so the team has to make impossible choices. What do we keep on? What do we turn off? What science do we sacrifice to buy one more year of listening? Years ago, the Voyager science and engineering teams sat down together and made a list, an order of shutdowns. Which instrument dies first? Which dies second? Which is the very last thing they will let go of before the probe finally goes silent. Imagine writing that list. Imagine being in that room. 7 of Voyager 1's 10 original instruments are already off. The plasma subsystem died in 2007. The planetary radio astronomy experiment in 2008. The ultraviolet spectrometer in 2016. The cosmic ray subsystem in February of 2025. And this is where the story becomes something happening right now. Because in April of 2026, just a few months ago, engineers at JPL sent the command to shut down another one. The low-energy charged particles experiment, an instrument that had been operating almost continuously for nearly 49 years. During a routine roll maneuver on February 27th, Voyager 1's power levels had unexpectedly dropped, and the team had to act before an automatic fault protection system did it for them. While shutting down a science instrument is not anybody's preference, it is the best option available, said Karine Badaratin, Voyager mission manager at JPL. Voyager 1 still has 2 remaining operating science instruments, one that listens to plasma waves and one that measures magnetic fields. They are still working great, sending back data from a region of space no other human-made craft has ever explored. NASA, the command took 23 hours just to arrive. The shutdown itself took another 3 hours and 15 minutes. That is what long-distance surgery on a dying spacecraft looks like in 2026. And right now, this summer, the team is preparing something they are calling, quietly, the Big Bang. A coordinated high-risk swap of powered devices designed to squeeze more life out of both Voyagers at once. Tests began on Voyager 2 in May and June of this year, and if they went well, the same procedure will be attempted on Voyager 1 no sooner than this July. If it works, humanity's oldest interstellar explorer gets more time. If it doesn't, we lose it forever. That is happening right now, not in a future science fiction movie. Right now, this week, this month, and now, here comes the specific moment I promised you. On Wednesday, November 18, 2026, at 2:16:77 in the morning Pacific Standard Time, Voyager 1 will pass a milestone that no human-made object has ever reached before. It will be exactly 1 light day from Earth. NASA 1 full, complete 24-hour light day, meaning that on that morning a radio signal leaving Earth at the speed of light, the fastest anything in this universe can travel, will need an entire rotation of our planet to catch up to that little gold-wrapped probe. If you send a command at breakfast on Monday, Voyager receives it at breakfast on Tuesday. If it answers immediately, you hear back on Wednesday. That is the new reality. 25.9 billion kilometers. 16.1 billion miles. Roughly the distance light travels in 86,400 seconds. No object made by our species has ever been this far from home. And come November 18, 1 will be. Now zoom out, because there is something almost sacred hiding inside all of this. Voyager 1 was launched by a civilization that had barely started using digital watches. It was built by engineers whose most advanced tool was a slide rule. It carries, bolted to its side, a gold-plated copper disc known as the Golden Record. Greetings in 55 languages, 90 minutes of music from Bach to Chuck Berry, images of children, whales, and rivers, curated by a committee chaired by Carl Sagan, a message in a bottle from a species that, at the time, wasn't even sure it would still be here to see the message received. That probe is now teaching us that the space between the stars is not empty, that it hums, that it rains gently, invisibly, in frequencies we could never have detected from Earth. It is the first physical extension of humanity into the greater galaxy. A tiny, fragile piece of us moving outward into the ocean of night, still whispering back what it sees. And it will not stop. Even after the last instrument dies, even after the last watt is gone, even after the last engineer JPL closes the file, Voyager 1 will keep moving. In about 40,000 years, it will drift within roughly 1.6 light-years of a small star called Gliese 445 in the constellation Camelopardalis. Not close enough to touch, not close enough to see, but close in a cosmic sense. Long after every one of us is gone. Long after our cities are dust. Long after the languages we speak are forgotten. That machine will still be out there, still carrying the greetings of a species that, in 1977, dared to say hello. And here is the mystery. The open question that Voyager has quietly left us with, and that nobody, not NASA, not the astrophysicists, not the engineers at Cornell, can yet answer. What is that hum exactly? We know it's there. We know it's real. We know it's the plasma of interstellar space, vibrating with some kind of structure, some kind of subtle organization, some pattern in the fabric of the galaxy that our models never predicted. But what is driving it? What is shaping it? Is it a whisper of the Milky Way itself? Is it the fingerprint of some larger process we haven't even named? We don't know. We only know it's singing. And somewhere out there, on the other side of the heliopause, a little gold-wrapped probe with a broken chip and a dying power supply is still listening. If this story hit you, please hit that subscribe button, ring the notification bell so you don't miss the next one, and tell me in the comments if you could send one sentence on the next Voyager. What would you say? Share this video with the one friend you know who looks up at the sky and wonders. And in the very next video, I'm going to take you deep into another impossible transmission from the edge of the solar system. One that involves a signal nobody expected, from a place nobody was looking. You won't want to miss it. See you there.